Alright, we are back. We are now looking for tangent lines. In exercises 35 through 38, we graph the given curve that's we have here, and then together with their tangents at the given values of x. And then we're supposed to label each curve and the tangent with its equation. So let's go ahead and plot what is the graph of y is equal to sine of x. And we're going to put it in this interval from minus pi over 3 pi over 2 up to 2 pi. So what does the sine of x look like? Alright, is this correct? Let's check. What is the sine of 0? Sine of 0 is 0. Sine of pi over 2 is 1. So indeed, that's true. Then it goes on like this all the way to 2 pi. And if we go to the left of 0, okay, it's the graph of the sine of x. And then our question is, we are supposed to find the line tangent to sine of x at these 3 points. But what I will do is just do one. Alright, so you do the rest of it. So why don't we say, I'll take x equal to minus pi, and then you try to do it at x equal to 0 and at x equal to 3 pi over 2. But so what do we need? Okay, in order to get the equation of a line, we need the slope, and of course we need a point. We already have the point, it's right here. So the point that we've given is this one. It's at minus pi 0. So minus pi 0. Now we need the slope. What is the slope? So where do we get the slope of the line tangent to the curve? It's going to be from the derivative. So y prime is equal to cosine of x. And then to get the slope, we substitute x equal to minus pi into the derivative. So that is the cosine of minus pi. And what is the cosine of minus pi? Go back to your unit circle. And it's right here where you graph where minus pi is. Starting from here, you go minus pi, and what is the x-coordinate of that unit circle? It's going to be -1, so that is your slope. Now that we have these two things that we need, now we use the slope point form. Y minus y1 is equal to m times x minus x1. And we have all the ingredients that we need. This is your x1, y1, this is m. So all we do is substitute. So we got y minus, what's the y coordinate of our point? 0 is equal to -1 times x minus, and negative pi gives us plus pi. And if you look at that, that's equal to minus x minus pi. So what is the equation of the line tangent to the curve? And it's equal to y equal to minus x minus pi. And where is it? It's this line with a slope of -1. So there I'm going to draw the line tangent to the curve, and we label that as our line y is equal to minus x minus pi. And it says to label everything. This is our curve y is equal to sine of x. And then the line tangent to the curve at x equal to minus pi is y equal to minus x minus pi. There we have it. And then, like I said, you try to work it out when x is equal to 0, and when also when x is equal to 3 pi over 2. So we're going to have a line tangent right here, and then when it's 3 pi over 2, it's right here. So you would be expecting a horizontal line for its tangent. Now here our graph is y is equal to secant of x. So what is secant of x? Remember, it's 1 over cosine of x. So if it's 1 over cosine of x, then let's go ahead and graph first cosine of x, right? Because secant depends on cosine. It's the reciprocal of cosine of x. So let's go ahead and graph the cosine of x. Now let's check if this is the graph of cosine of x. What is the cosine of 0? It's 1. Cosine of pi over 2 is 0. And cosine of pi is -1. So we are under, this is the right curve. Then we take the reciprocal. So what is the reciprocal of 1? It's still 1. So that means it should appear right there. And then you see how the cosine decreases to 0. What happens to its reciprocal? Remember when we talked about the limit of 1 over 0 in a positive sense, that is going to go to what? Plus infinity. There it is. And then when we approach minus pi over 2 coming from the coming from the left, these are your cosine values, and it's decreasing. If I'm coming from the left, I'm going down, it's approaching 0, which means its reciprocal would then approach positive infinity. And then you're going to have the same one on this side. But really what we are concerned is the interval from minus pi over 2 up to pi over 2. And then why don't we just, I'll do x equal to minus pi over 3, and then it'll be your turn. You go pause this video and then try using plotting the line tangent to the curve, or finding the line tangent to the curve at x equal to pi over 4. Okay, so let me go ahead. I'll do x equal to minus pi over 3. So what do we need? We need the point. So what is the point? When x is equal to minus pi over 3, what is the secant of minus pi over 3? Well, what is the cosine of minus pi over 3? That's in the fourth quadrant, and so what's the cosine? It's positive. Remember, pi over 3 is a 60-degree angle, so what's the cosine of a 60-degree angle for your reference? Is 1/2. So take the reciprocal, you get 2. So that means the secant of minus pi over 3 is 2. So let's locate that point. You have a minus pi over 3 right about here. And so your x is this, your y is 2, so just right there. Because remember, this is 1, so that ought to be 2. There's your point. Now, you expect that if we draw the line tangent to the curve right here, what is the slope? What do you expect to be the slope? It has to be negative. Let's see if that's the case. So we already have a point. What do we need next? We need the slope. So what is the slope? We get the slope by taking the derivative of secant, and it's equal to secant x tangent x. Okay, and what's the slope? Just plug in at the value of x that we are trying to evaluate. So it's the secant of minus pi over 3 and the tangent of minus pi over 3. Now the tangent of minus pi over 3 is, with its reference angle, still the 60-degree angle. So what's the tangent? It's square root of 3. But because you're on the fourth quadrant, remember that the sign of tangent in the fourth quadrant is negative. So you're going to have, and remember, what is the secant? It's 2. So the secant of minus pi over 2 is 2 times tangent is negative square root of 3. So really the slope is equal to minus 2 square root of 3. So are we ready to plug in our slope point form? I think so, because we've got the point and we've got the slope minus 2 square root of 3. So what is the equation of the line? Why don't we put it right here? Let me just remove this part of the secant, and then we can put y minus y1 is equal to m x minus x sub 1. So that's equal to y minus 2 is equal to negative 2 square root of 3 times what? X minus negative pi over 3 gives us plus pi over 3. And so there we have it, folks. We've got the slope point form, and the rest is just simplifying, but that's it. Basically what the equation of the line tangent to the curve. But what is the slope when you say negative 2 square root of 3? Well, square root of 3 is approximately 1.7. So when you double it, it's like 3.4, and it's negative. So let's see, would that look like that? I think so. We have that slope right here. And it's a negative, and so that's the line tangent. So let's call it T maybe. And this is the graph of your equation y is equal to secant of x. And there, this is our equation of the line tangent to the curve. So this is our tangent line. And we are done. We have finished section 3.5, and go work some exercises and finish the rest of this problem.